Welcome back, my dear friends. A very good morning, good afternoon, good evening to all of you wherever you are in this part of the globe. And as you know, this is the DADM 3, which is data analysis and decision making 3, which is being shown on this slide under the NPTEL MOOC series. And as you know, this is a course under for which the total duration is in number of weeks is 12 weeks, which when converted into number of hours, contact hours is 30, and each lecture is basically for half an hour, and each week, as you know, we have 5 lectures. So, total number of lectures would be 60 in number. Now, as you can also know that we have already completed 4 weeks, which is about 20 lectures are already completed, and after each week we have a set of assignments. We have completed 4 assignments, and we are going to start the 5th week. After another 5 lectures of half an hour each, we will have the 5th assignment. And my good name is Raghunandan Sengupta from the IME department at the IIT Kanpur. So, if you remember, we were discussing about the concept of primal dual problem. That means a problem, primal dual are interchangeable words, means if I have a maximization and a primal, then the minimization is dual, or if the minimization is primal, the maximization is dual, where we convert the number of rows into or the number of constraints into number of decision variables and vice versa, depending on how you want to solve the problem, and the greater than sign, less than sign, the unrestricted part, all these things we have discussed in the last class, which is on the 20th lecture. Now, as you see, this is the 21st lecture in the starting of the 5th week. Now, let us consider a problem, and we will also consider its duality later on. So, company considers has 2 different products. So, mark the thing as 2 different type of glass products, and it has 3 factories. So, if you consider, there are 2 decision variables here and there are 3 constraints. So, now I will be switching from the concept of how you solve the problem from the primal one into the dual one. The concept of solving would remain the same, but the formulation is what is important. So, if you have 2 different types of glasses, and if these are the 2 decision variables, which is x1 and x2, and if there are 3 constraints pertaining to the factories, when you convert that into a dual, there will be 3 decision variables pertaining to the factories and 2 constraints pertaining to the decision variables in the initial primal problem. Now, this if it is a maximization problem, you will have a counterpart in the dual case, which will be a minimization problem. So, let us first solve it, and then we will come, once the overall algorithm is mentioned, we will come to the dual problem solution also. So, company, let me read it. A company which produces 2 different types of glass products has 3 factories, and the data for the same is as given below. So, the plant P1, P2, P3 are given along the first column on the left hand side, and the product, which is 1 and 2, is given in the second and the third column. These are the capacity per unit production rates, and the capacity available from plant 1, plant 2, plant 3 are respectively given as 4, 12 and 18. So, they can be into 10 to the power 3, 10 to the power 4, does not matter, I am just giving the numbers, which means that in plant 1 you can produce only one product, which is product 1, and 0 product 2, and the total capacity utilization is 4. So, you can produce maximum 4 units of product 1. Similarly, for plant 2, depending on the setup which is there, you can produce 0 number of product 1 and 2 number of product which will be produced. So, per unit capacity utilization, what I am saying, and capacity available is 12. Consider that product 2 requires 2 machines, and you have 12 total machines in plant 2. So, you can produce maximum of 6 products in plant 2. Finally, when you come to plant 3, it has got 18 total units of capacity utilization. Consider that each unit of product 1 requires 3 units of capacity utilization, and each unit of product 2 requires 2 units of capacity utilization. And if I consider this production, obviously there would be a profit. So, unit profit I am considering. So, obviously it means that I am calculating using the concept of selling price and cost price. So, the unit profit which I get from product 1 irrespective of the plant is 3 units, and the unit profit which I get from product 2 irrespective of plant is 5 units. So, if I want to basically formulate the primal problem considering is a maximization problem, it will be x 1 and x 2 is basically for product 1 and product 2. So, the unit production if it is 3 and 5, it will be 3 x 1 plus 5 x 2 which you want to maximize corresponding to these 3 constraints pertaining to plant 1, 2 and 3. Now, the model formulation if you do it, which is very simple, it basically becomes maximization of 3 x 1 for 5 x 2 depending, because 3 x 1 y 5 x 2, because if you see, so this 3 unit is coming from 1 unit of product 1 produced, this 5 unit is coming from 1 unit of product 2 produced. So, it is 3 x 1 plus 5 x 2, and what are the constraints? If you remember, I mentioned that plant 1 can only produce product 1, plant 2 can only produce product 2, while plant 3 can produce both of them. So, if I bring them into the situation, it will be x 1 is less than equal to 4, 2 x 1, because we are utilizing 2 units from plant 2 to produce the product, 1 unit of them. So, if you are producing x 2 unit of them, it will be consumption will be 2 x 2. And why it is 12? Because on the right hand side the constraint of utilization in plant 2 is 12. So, it is 2 x 2 is less than equal to 12, and for plant 3 the total utilization is 18 corresponding to 3 units being consumed by product 1 and 2 units being consumed by product 2. So, it is 3 x 1 plus 2 x 2 is less than equal to 18. Now, remember here all of them are less. So, obviously, if they are less, you have to understand that what you will going to add, slack or surplus depending on the problem. So, obviously, it would mean that if you are able to produce in product in plant 1 all utilization is 100%, that means you will produce maximum 4 units of product 1. Similarly, if you produce all units in plant 2, all capacity utilization is maximum, then only produce 6 units of product in product 2 in plant 2, and similarly the combinations can be thought of if you produce basically some combinations of product 1 and product 2 in plant 3. And obviously, as per the assumption these products have to be produced in positive numbers. So, x 1 is greater than 0 and x 2 is greater than 0. Now, we will introduce the slack variable, slack because they are lagging behind. So, you want to add slacks. So, introduce the slack variables which will be red in color for the less than equal to sign, and obviously, remember one thing, if you are converting the less than sign into the greater than sign corresponding to the dual problem. So, in place of slack the surplus will come with a negative sign. So, introduce the slack variables which are shown red in color such that equality can be brought into the picture. Thus, we will have the problem maximization. So, the slacks would be what? There are 3 equations, there will be 3 slacks which we can denote by S 1, S 2, S 3, but we have denoted it as x 1, x 2, x 3. X 1, x 2 is basically for the variable. So, obviously, they will be x 3, x 4, x 5. So, the first constraint would be x 1 plus x 3 which is equal to 4, where x 3 is the slack corresponding to the first constraint. The next constraint would be 2 x 2 plus x 4 is equal to 12, where x 4 is the slack corresponding to the second constraint. And the last equation, which is the third one, would be 3 x 1 plus 2 x 2 plus x 5 is equal to 18, where x 5 is basically the slack corresponding to the third constraint. So, here also as we know we will formulate the problem where x 1 x 2 is obviously greater than 0, but we will also bring the slacks to be greater than 0. So, that means x3, x4, x5 are greater than 0. Now, we will basically write the tableau. Tableau is basically from where we need to start. So, we can have different basic feasible solution. So, we will consider the origin. Considering the origin is a feasible solution, we will consider the origin as the starting point. So, how do we do that? So, we write the basic variables along the leftmost column. So, the first variable which you write is z, which you want to maximize. So, now if x1 and x2 which is 0 point, it is the basic feasible solution. So, if you put 0, so let us come back here. If you put 0 for the first equation, so x3 becomes 4. If you took 0 for x2 in the second equation, x4 becomes 12, and technically as x1 and x2 are 0 in the third equation, x5 will be 18. So, hence when we start, the actual vector corresponding to the basic feasible initial solution is 0, 0, 4, 12, 8. Now, pause, ask yourself, is this a feasible solution? Yes, because all of them are non-negative, hence you can start your iteration process based on the point 0, 0, 4, 12 and 18. So, let us check what we have said actually matches. Now, we will write in the second column, which is here as the equation number. So, 0 will be the equation number corresponding to the objective function, whether maximization or minimization does not matter. The first constraint would be numbered as equation number 1. So, let us see, okay, let us first see the equation 1. So, if you remember, I had mentioned that what you do is that you bring all the variables onto the left hand side to the equality sign. So, now it was initially 3x1 plus 5x2 was the objective function which was trying to maximize. Now, when you bring the slacks into the position, you will basically have 3x1 plus 5x2 plus 0 into x3, because why 0? Because there is no component of the slack which is going to come into the objective function. The fourth term is plus 0 into x4, because the component for the second slack which is coming from the second constraint is not applicable for the objective function, plus last term would be 0 into x5, where x5 is the slack corresponding to the third constraint, which would definitely not have any bearing on the objective function. So, when we bring all this term to the left hand side, you will have minus 3x1 minus 5x2 plus 0 into x3 plus 0 into x4 plus 0 into x5. Here the red color denotes the slacks. So, now if x1 is 0, x2 is 0, and automatically x3, x4, x5 even they have the non-zero, they are 4, 12 and 18, because the parameter values by which they are being multiplied individually are 0. Hence, the objective function when you start off is 0, which is shown here. Now, I want to basically optimize. Now, let us go to the constraint 1, 2, 3. The first constraint, if you note it down, it was only related to x1. So, now if you consider x2, x3, x4, x5 is equal to 4, obviously the variable corresponding to x1 is 1, which is here. So, I will mark the equations accordingly. So, so it will be 1, while the corresponding parameter values corresponding to x2 will be 0, because x2 is not there in the first equation. x3 will be 1, because x3 is coming out as a slack for the first constraint. x4 is not there because it is the slack corresponding to the second constraint, and x5 is 0 because that is the slack corresponding to the last constraint. So, hence the parameter values which we will multiply, z is 0 obviously as per the norm, because we will consider that as the nomenclature, 1 x1 plus 0 x2 plus 1 x3 plus 0 x4 plus 0 x5, and the right hand side is 4, because if you put this equation, actually what it means is that as x1 is 0, so obviously it becomes 0, x2 is technically multiplied by a factor 0, so it would not be coming to the picture, because x2 even if, and as such it is also 0, x4 and x5 are being multiplied by 0, so they will not come to the picture. So, only thing which you have is basically 1 into x3 is equal to 4. Now, let us come to the second equation, and I will use a different color. The second equation now has an equation where x1 is 0. So, obviously, it means 0 into x1, x2 you know that it will be multiplied by 2. So, 2 into x2, x3 is not there in the second constraint. So, it is multiplied by a parameter 0, x4 is there in this constraint which is the second one. So, x4 is multiplied with the value of 1 and x5 is the constraint pertaining to the last constraint. So, obviously, it would not be there. So, it is 0. Now, if you see the equation, it will be 0 into x1 plus 2 into x2 plus 0 into x3 plus 1 into x4 plus 0 into x5. x2 is 0. So, obviously, this vanishes, x3 and x4 are not there. So, the value of x4 if you put it on the right hand side becomes 12. So, now we are double checking that the value of x3, x4 are 4 and 12 respectively. Let us come to the last equation. So, this is the value which we have, x1 was there, x2 is there, and obviously, I will put the color of 0, yeah, this is true, this is true. Now, I come to the last equation. Let me use the color of blue. So, the third equation had 3 x1 plus 2 x2 plus x5 is equal to 18. So, x3 and x4 are not there. So, they are being multiplied by values 0. So, let us check 3 into x1 plus 2 into x2 plus 0 into x3 plus 0 into x4 plus 1 into x5. Now, what is there on the right hand side? 18, and why it is 18? Because if you put x1 as 0, x2 as 0. So, everything x1, x2, x3, x4 vanishes. So, the slack value x5 is 18. So, let us mark these values, and also I will use a color scheme of this. Now, let us pause and look at this matrix. Look at this matrix. What is it? It is an identity matrix. So, what we want to do is that convert, because x3, x4, x5 are the basic feasible solution from where it is starting. So, technically when we stop the iteration, the values pertaining to slacks x3, x4, x5 should be 0, actually should be 0, because it would mean that we have been able to utilize the overall utilization of the machine of plant 1, plant 2, plant 3 to the maximum possible extent, such that we are able to produce the product 1 and product 2 to the maximum possible extent and gaining the maximum profit. So, actually what we want to do is that once we finish, so in place of x3, x4, x5, x1 and x2 would definitely be there and any one of the other slack. So, you will have either x1, x2, x3, x1, x2, x4 or x1, x2, x5. x1, x2 would be non-zero, and this 3 or 4 or 5 whichever the slack variable would be there would be 0, corresponding to the fact that overall utilization is 100% in all the 3 equations. So, if it is x3 is 0, by calculation it means that x4 and x5 obviously not there, x3 is also being forced to be 0 depending on the utilization. Now, let us read the problem. Your main task is to replace the basic variables with the actual real variables or decision variables which are x1 and x2. For your case it is x1 and x2 as I mentioned, and there would be additional slack variables also. As this is a maximization problem, then we should make a decision which one of the variables should leave and which one of the variables should enter. So, who are the contenders to enter? Actually, the contenders to enter is x1, x2, x3, x4, x5 actually, and the contenders to leave are x3, x4, x5. So, if x3 is entering, it may be possible that so obviously if if x2 is entering, it may be possible that any one of x3, x4, x5 can be leaving. If x1 is entering, it may be possible that x3, x4, x5 is leaving. So, we will check the validity of that statement. So, as this is a maximization problem, then make a decision which one will be the entering variable such that it has the largest non-negative coefficient. Again I am repeating, I have repeated it. So, if you consider the largest non-negative this non-negative coefficient in the sense one additional unit of x1 being produced or one additional unit of x2 being produced will increase the objective function by units of either 3 or 5. That means, z will now become z initially 0 plus 3 or 0 plus 5 depending on 1 unit of x1 or x2 coming to the picture. Now, you name the column corresponding to this entering variable as the pivot variable. So, there would be a entering variable and there would be existing variable, and we know the common element to this column and the row would be the pivot element based on which you will do the calculation. Now, we will choose x2. The reason is very simple, because addition of x2 would increase your objective function by 5 units, while addition of x1 will increase your objective function by 3 units, because it is a maximization problem. So, x2 should be the entering one. Now, let us see who will leave, because x2 if it comes it will push out 1. So, let us see who is that one. Now, what we do is that if 5 due to plus 5 addition for x2, if this is going to add, so let us check the rule. So, if the variable enters, one has to leave, which is true. We now have to decide which variable will leave. Now, we will calculate the ratios. What are the ratios? Ratios would basically be per unit addition or subtraction, how the objective function is changing, whether it is a maximization and the minimization problem. So, let us read it. Calculate the ratios. What are the ratios? One ratio is right hand side you have the vector. So, it is 4 by 0, because in case if x2 is coming and x3 is going, for pertaining to equation 1, the overall loss which you will face, loss or profit depending on how you are looking at the problem from the maximization problem and the minimization problem, would be 4 by 0 for x3. Loss of profit which will pertain for 1 unit of leaving of x4 would be 12 by 6, which is 6, and 1 unit for leaving of either for not for x4, but for xy would basically have a effect of 18 by 2. So, let us read. Calculate the ratios of 4 by 0 not defined, hence they would be left out. 12 by 2 will be 6 for x4 and 18 by 2 would be 9 for x5. So, choose the one which has the ratio is the smallest, because why it is smallest, we will consider for the maximization problem, number 1 who is entering would give you the maximum benefit, and number 2 who is leaving would basically not be affecting your objective function to that possible state, because if one variable is leaving, obviously technically the objective function would be coming down, but that reduction in the objective function, if it is the maximization problem, should not happen to that possible extent. So, you will take the minimum value, and the one who is entering would basically give the maximum credit to the objective function, hence it increase would be maximum. That is why x2 and the leaving one would basically be the one for which is the lowest one. So, the column marked is basically the pivot column corresponding to basically the value of x2, and you will decide the corresponding pivot element accordingly. Now, we will consider the value, because 4 by 0 is undefined. So, we will basically take the value of 12 by 2, which is 6. That means, 1 unit of x4 leaving would technically decrease your objective function by 6 units. 1 unit decrease of x5 would basically decrease your objective function by 9 units. So, we will take the first one. So, choose the row corresponding to this as the pivot row, and the element common to the pivot column and the pivot row, which is 2, is the pivot element based on which we will start the calculation, which means based on that we will start the calculation to find out that how we are going to change and utilize the Gauss-Jordan method to convert that initial basic physical solution in the final solution. Hence, x4 will leave, which is known and given as red, and x2 will enter, and 2 is the pivot element based on which we will do the calculation. So, once this is done and if x2 comes, what we will actually do is that we will basically aim the elements multiplication and addition in such a way that we will slowly convert the pivot element corresponding to x2, because x2 has entered and x2 is also there in the row. So, the column and the row, the actual value would be 1, because in the end of the day the whole row corresponding to x2 should have only one element, which is 1, and the right hand value which you will have on the rightmost column would give you the actual value of x2 based on which you will do the calculation. So, let us see. So, how are the new rows formed? The new rows formed would be the old row minus the pivot column coefficient into the new pivot row. So, if you are considering that concept, so the pivot element is 2. So, that 2 would definitely be utilized in that calculation such that the common element which I mentioned few minutes back, the common element which is there between x2 as a column and x2 as a row should be 1. So, let me consider. So, equation 1 has changed as per the following calculation based on this fact. Initially it was -3 -5 corresponding to x1 x2 and all x3 x4 x5 was 0. So, it is there x3 x4 x5 and the last one was basically objective function which was initially 0. So, the minus, so this element pivot column coefficient was -5 there because that was basically the entering one, and the new pivot row which you would have technically initially if you consider, let us consider this, when you convert it, sorry, when you have basically divided and converted would basically be 0 corresponding to x1, 1 corresponding to x2 which I just mentioned, 0 corresponding to x3, half corresponding to x4 and 6 corresponding to x5. So, when you do the vector multiplication, so the actual value which will come out in equation 1 would be -3 for x1, 0 for x2, 0 for x3, 5/2 for x4, 0 for x5, and the right hand side value has now become 30, which means the objective function has increased by a unit from 0 to 30. So, if you stop here, let us stop, it will give you an indication. So, if you just pause here, let us have a look. I will read the equation 1, 2, 3, okay, I will read the equation 1, 2, 3 first and then I will come to what I was going to explain. So, equation 1 has changed as per the following calculation, because the element based on which you will multiply is 0, because that entering and exiting variables pivot element is being converted. So, it will be 1 0 1 0 0 4 as per the new the column which you had, old row which you had, and the element which you will multiply is 0, hence the actual value which remains, because if you are multiplying by 0 remains the same, it becomes 1 0 1 0 0 4, that it just does not change any value because you are multiplying it by 0. Similarly, equation 2 would be as has been changed as per the calculation, because you are now dividing by 2 only. So, dividing by 2 would basically make it as 0 1. So, this one is very important to note. So, what I am trying to do is basically trying to convert that actual that actual value as a identity row or a column in the actual calculation when it ends. And the third equation changes according to the same concept, the new row is equal to old row minus the pivot column element in the new pivot row, and the value comes out to be 3 0 0 minus 1 1 and 6. Now, what I was going to repeat, let me come back. Now, if the calculation suddenly stops there, you do not want to proceed. So, you will try to check that this value of 30 in the objective function, how did it come? Now, let us go back to this calculation. Now, let us check that what is the actual identity matrix which you have. So, identity matrix now which you have looks very interesting. So, it is 1 unit in factory 1 plant 1, 1 unit of x, if x3 is only being produced, x1 and x2 are not there because x2 was not being produced in plant 1. So, obviously, the total slack of x3 always remains 4. Now, if I go to plant 2, now plant 2 does not have any x1, which is fine. Plant 2 does not have any value corresponding to this of x3 also is not there, and the value which is basically corresponding to x4, even the parameter is half, but the actual value of x4 is 0. So, obviously, half into 0 would basically give you a 0 value, and x5 is basically 0 in plant 2 because it is not a slack for the second constraint. So, the actual value which you will get in x2 would be 1 into x2 is equal to 6. So, that will give you the value which is corresponding to 6 units of x2 is being produced. Now, pause here. What was per unit profit which is coming by 1 unit of x2? It was 5. So, 5 into 6 is your objective function value which is 30 here. Finally, x5 if you consider, you are getting, so x1 is not there, so x1 value is 0, so 3 into 0 is 0. x2 is in plant 2, obviously you will see that the plant 2 is does not have any value which is being produced for the value of 2, and x3 value is 0 and x4 value is -1, but the actual value which you will have for the slack corresponding to plant 3 is x5 which is 6. So, with this I will explain this in the next steps and come with the dual problem also, and then see that how they merge and they give you the answer. I will continue in the 22nd lecture the discussion about the primal dual problem, the simplex method, and it can be increased to any other higher dimension also. Have a nice day and thank you very much.